So today we're talking about Chapter 5, which is solving systems of equations. We are responsible for two sections out of this chapter, 5.1 and 5.5. 5.1 would be the linear systems, like linear lines and how they cross. The system means you've got more than one equation. And of course this linear would be lines. So we're looking for where these lines cross. That's the solution, where they intersect. In 5.5, it's the same idea, but they're nonlinear. So we might have a circle with a line going through it, so there could be more than one crossing point. All right, so to get us started, I've got a system of equations, two linear equations, and say we were looking for the solution to this system. Now, if I didn't have this second equation there, and it said, what's the solution to that? It's not a system now, but the solution to that equation, there's lots of solutions. 4 and 3 is 7, so 4, 3 is a solution. 1 and 6 is 7, that's a solution. 5 and 2, and on and on and on. There's infinite solutions to just one line, and we draw that, and that's what we call graphing, and connect the dots and show that it's a line. But when I put a second equation up there, in the linear explanation, a second equation up there, now there's just going to be one answer to that. What makes this equation true and this equation true? And you might think about it and come up with something that works on that one. So if you've got it, go ahead and feel free to share. 3 and 4. 3 and 4 does work. 3 plus 4, or I'm going to do it as 4 plus 3, so the x will be 4. 4 plus 3 is 7, and then 4 for x minus 3 for y would also equal 1. So there is one solution to that. And that would be where the lines, if you physically graph these, took time to graph the solutions to that one and graph the solutions to this one, they would cross or intersect at the point 4, 3. So that's really what we're doing. That's the big picture of what you're doing in Chapter 5, is you're looking for the crossing intersection point. So we have different methods for finding that. We have 3 methods actually. One is just to graph them. If you could graph each one of these lines on a gridded paper, or if you're using a graphing calculator, you can look for the intersection point that way. If you are a graphing calculator user, you know you have some prep work. You'd have to solve each one of these equations for y, rearrange it, and then plug it in. So that is an option if you want to pursue that option. The second way is the substitution method. And the third way is elimination, or the addition method. And sometimes one or the other is kind of better fitted to the problem, but really you use any method that you want. We're just trying to get that solution. So looking at these two equations, I would say it's most suited to elimination. Directly, I could use elimination, which is just add straight down and find the solution. So if I were to add these two equations, I would have x and x is 2x, y and minus y cancels. That's what you want to happen in the addition method. 7 and 1 is 8. And now we have a solvable equation. We can divide out the 2 and get to a solution that x is 4. So remember, the solution is an x and a y. So once I get x is 4, I'm not quite done. I have to go back up into either one of the original equations and find its y value by substituting in x is 4. So whichever one looks easiest, I would say here 4 plus what is 7. So you can plug it in for that x and say what plus 4 plus what equals 7. You can solve that to get the solution of 3. So now we have the solution 4 for x, comma 3 for y. And to know for sure, and as we go through these other problems, the way you're going to know for sure you got the right answer, you can check it, plug those back in, make sure both of those work in both equations. All right, so that's our main idea. What I'm going to do now is I'm going to move to your final study guide and work the problems using these methods that we see there. So the final study guide, starting at number 50. Brown marker, see if it's any brighter. Okay, notice the directions on number 50 says solve by substitution. But if you say, I really like the addition method, that's fine too. If you were going to use the addition method I just illustrated, I would times one of these equations through by a negative sign, so these would be opposite y's. That would be probably what I would choose to do on that. But I am going to solve it by substitution per the directions. So here's how substitution works. You look for one of your 4 variables in your problem, whichever one looks easiest to solve for, which is this x. It's just a 1x, so you can throw the 3y across the line. So solving for this x, you would have positive 3y minus 31. Then with substitution, you sub in what you just got for x equals that. You solve it in or substitute it in to the other x in the other equation. So that makes the equation 2, instead of x, these are interchangeable, we call it 3y minus 31 minus 3y equals negative 35. And then this is solvable at that point. I'll let you pause.